Okay. Let's solve one more problem. Constructing push-to automata with the language. Okay. That consists of the string W. Language consists of a string in which the number of A's, okay, in the string should be equivalent to number of B's. Okay. This case also we'll be able to construct a push-to automata. So what can be a string? String can be AB. So there is a single A and there is a single B. It's okay. Number of A's are equivalent to number of B's. Suppose a string can be AB, AB. Okay. There are two A's and there are two B's. A string can be B, A, B. There are two B's and there are two A's. Like that, you can consider any string that has the equal number of A's and equal number of B's. In this case, simply you can construct a push-to automata, right? So what is the condition? Here also you have to fix the condition when you need to perform push operation and when it is pop-out operation. So if it is A, okay, whenever A comes, A should be pushed into a stack. When B comes, it must be popped out from the stack. This is the condition so that your stack will be empty when you process the particular string. Let us start writing the transition function. Okay, in state Q0, initial state, right? Q0 is our initial state. So the starting symbol itself, it can be A. So in that case, it can be Q0 comma A is not. Then, so it may start with B also. So if B is the initial symbol, it can be Q0 comma B is not. Suppose in the same state, if the input symbol is A, okay, input symbol is A, on the top also we have A. That case, you can perform push operation. Am I right? Suppose on the top of the stack, if you expect, what's that? B, and if your input symbol is A, what we are doing? See, on the top we have B, but the input symbol is A. So you have to perform pop-out operation. Okay. See, you can perform pop-out. You can, let us keep the same state when we perform push and pop operation. Here we have to include one more. Okay. See, on the top of the stack, if we have B, and if the input symbol is also B, in that case also, that must be inserted into a stack like this. Then, what you have to do next step, transition function of Q0 comma, on the top if we have A, and if B comes, then it should be pop-out operation. Clear? Okay. Suppose all the combinations you have to think. In state Q0, okay, if A is on the top of the stack, still if B comes, right, for this we have given a transition function. When A is already there, then we have performed a pop-out operation. So we have, see, these are all for pop and these are all for push. And for pop, that's all. Right? The last step, Q0 comma epsilon comma, there are no more symbols to process. Then we can go to the final state. So this case you can write Q1 comma epsilon or Q1 comma epsilon. How can you give a transition function? We have Q0. Okay. And we have Q1. Q1 is our final state. In Q0 itself, we have performed push and pop. So write it A comma Z0, A Z0, B comma Z0, it's B Z0. Then A comma A, it is AA. B comma A, sorry, B comma B, it is BB. Then for pop-out operation, write down, okay. So A comma B, it is epsilon. For B comma A, it is epsilon. Okay. Then epsilon comma epsilon, it is epsilon. That's all. This is the transition function diagram. Transition diagram for the language that consists of equal number of A's and equal number of B's. Hope it is clear to all of you.